Good afternoon, everybody. I'm Melissa Erickson. A lot of you have seen me around here or know me from conference calls as Mel. I'm here today to represent Michigan State University. I'm going to show you some of our prelim results. I'm also going to discuss our objective, setup, collection, and some of our results. I'm also going to show you some supportive data from a multi-year project that is near our site. Topography is one of our main factors in plant performance. We see three elements that help with this: water distribution, material distribution, and microclimate. And microclimate, I'm using it as a 24-hour period on the landscape. Our research is based off of topography. So we're looking at small experimental fields, which are uniform, have really good soils, but we also, within those, have experimental plots, which again are very uniform. As you can see, the picture on the left would be our plot, and this is from KBS. The plot on the right, if we drive through the countryside, this is what we're going to see. So we need to take what we see in the plots and give it as a broader perspective to these variable fields. So my focus is the impact of topographical variations on cover crop performance and how they contribute to corn growth and yield. These are two experimental fields in Michigan. You see in red in southwest is Kellogg Biological Station, or KBS for short. In blue, you see that this is our Mason site in central Michigan. The picture on the left will be the sites that I'm referring to. These are our scale-up fields at KBS that surround our fields. Our experimental setup with the plots, there's two replicating blocks. Each of them have a summit, a slope, and a depression. This just happens to be the KBS field looking south to north view. You will see on the left is our slope, middle is our depression, and to the right is our summits. The color variations represent elevations, green being lowest, brown being highest. For our data collection, we have collected baseline data as part of the Objective 2 task. We have collected on a daily basis greenhouse gases, soil moisture, and temperature. As part of the grant work, we have set up a 2-year rotation. Our rotation is corn, soybean, and in May, you see that we start our corn, harvest in October. In November, we start our rye planting. In May, we terminate. Again in May, we start the soybean. In October, we harvest. November, again, we plant rye, and we terminate it in May, and we start the cycle all over again. The bottom graphs show you that this was this year's process. In October of 2011, we harvested grain yield and whole plant biomass. In May of 2012, we collected rye cover crop, and in June of 2012, we collected corn biomass at stage 5. V5. Now I'd like to take you through some of the results that we have come across. We'll start with soil texture. As you can see with Mason, depressions are a lot higher. However, in KBS, we see that slopes are higher. From these graphs and from the pictures below, which on the left is Mason soils, on the right is KBS. We can see that the KBS soil is a much sandier texture. Now for our organic matter. We see that depressions are a lot higher than slopes and summits. Reasons for this are depressions are wetter, and also your organic matter is transferred to lower areas of the landscape. Also, I'd like to call your attention that the top first 0 to 10 centimeters is the highest. As you go down in depths, it decreases. For our October 2011 collection, it was heavily influenced by late planting date. We were unable to get into the fields because of an extremely wet spring, so our planting did not occur until June 22nd. As we can see, the highest yield was in depressions, followed by summits, and then slopes. The difference between the two sites could possibly be the sandier soils at KPS. Corn plant biomass from June, we see the same trend. Again, depressions are higher, summits, and then slopes. However, we see a trend change. Interestingly, we see that for the cover crop, summits are higher, followed by depressions and slopes. We see the next slide being soil moisture. On the x-axis, we see the depth, y-axis, soil percent. We see a higher soil moisture and lower temps in depressions during wet springs, which could cause poor cover crop performance and topography in depression areas. This is one example of data taken one day at KBS. Now I'd like to show you some of the supportive data that is on our other project for a multiple year. This is located at LTER scale-up fields. They go by a 3-year rotation, which is corn, soybean, and wheat. Also, you will see on the x-axis T3 and T4. T3 represents a low input, T4 is organic management. From these previous experiments, it indicates to us that there was a 3 to 4-fold topography difference in the rye biomass in a single year, and a 2 to 3-fold variation among different years. This graph we see on the x-axis red clover biomass and corn yield. As you can see in depressions, with the amount of biomass, as it increased corn yield, they both were in relationship with each other. There was no increase in either one. However, when we got to depression, or in summit and slope, we see a difference. We see that higher red clover produced higher corn yield. And mind you, on our project, we will not be using red clover, so our data will vary. And just so that you see there is progress on GHG, we have put together a graph with cover and no cover. And as you can see, there are differences in the depression. However, we don't see any differences in summit and slope. So we have the interaction of the carbon dioxide flux and how they interact with the topography and the cover crops. So in conclusion, we've come up with soil properties varied by topography, that depressions had higher organic matter. For the corn, we see that the main growing season was optimal in depressions, followed by summits and slopes. Corn yield was also highest in depressions. For cover crop, in the spring, we saw a pattern change where summits were higher. Also, biomass was higher in summits, lower in depressions. Our higher temperature, our high soil moisture and low temperatures in depressions, again, were due to wet springs. And they could be the cause of cover crop performance in topographical landscapes. And a good point that probably came out of this research, for me at least, a positive sign is that a good crop performance in summits and slopes could give us a promise as a carbon sequestration tool, especially where there is low organic matter in slopes and summits. I would like to take this time to thank the funding agencies, Michigan State for their support, MSU, LTER, and CSCAP colleagues for their time, the work, and their supportive data for this project.
We have time for one question. Someone have a question that they'd like to ask?
Yes.
And I'm wondering whether there was nitrogen fertilizer applied to that, whether the clover effect had been due to a nitrogen contribution to corn crop. Do you know if it's fertilized or not?
I believe it was. I'm not sure. I'd have to check.